Hello, everybody. We're back for the next talk. So the next speaker is Edoardo Vacchi. Edoardo, can you introduce yourself?
Hi, I am Edoardo, and I really like programming languages. Hi. Should have said, hi, Edoardo. Thank you.
Okay, so and which programming languages are you going to talk about today?
Well, quite a few, actually.
Quite a few?
Yeah.
Okay.
Yeah.
I met with some people earlier who were coming from a Scala background. Are going to mention Scala?
Yeah, we're going to mention Scala.
You're going to mention Scala?
Yeah. Yeah.
Okay, awesome. So then please give it up for Edoardo and let's hear the talk.
Thank you. All right, and welcome to Abstract Factories, Zygomorphisms, and you, the role of social interaction in language ecosystems. So, throughout this talk, we're going to answer a very simple question. Do languages shape thought? So, philosophers and linguists have tried to give an answer to this question. There's no definite answer, especially for spoken languages. So, you might have heard of Wittgenstein, the limits of my language mean the limits of my word. And that was later refined as in the limits of my language are the limits of my mind. All I know is what I have words for. So, this is sometimes known as the Sapir-Whorf hypothesis, which is kind of a controversial hypothesis. The idea is that the structure of a language influences the worldview or cognition of the speakers, and that means that the language literally determines or shapes the way people can feel and perceive the rest of the world. So that's kind of a strong hypothesis. As an example of this, sometimes you might have heard about the snow, words for snow in the Eskimo language. They say there are hundreds of words because they, depending on the shape, the color, they have a different word. And actually, this is also controversial, and it seems to stem from a misunderstanding how words are composed in the Eskimo language. Actually, the roots are like 3, and then the rest of the words are more like phrases, right, with attributes. So there is a strong version of the Sapir-Whorf hypothesis, which is also called linguistic determinism. And this is literally meaning that language determines thought. You can't literally formulate thoughts if your language does not include a concept in the words that you can say and express. If you're familiar with 1984 and the concept of the language Newspeak, that language was an artificial language that they created by removing words from the vocabulary so that people could not formulate, since they didn't have the word, any thought about liberty and freedom. There's also a weaker version of the Sapir-Whorf hypothesis. This is less controversial. Structures in a language influence and shape the perceptions, but they do not obstruct or limit the thoughts of the people, right? Okay, so this is for natural languages, and as we saw, it's kind of controversial. What about programming languages? Even here, a lot of thinkers, a lot of computer scientists, mathematicians had something to say. So this is a Dijkstra, and in the Humble Programmer, it talks about Fortran. First, it says, a major development of the software scene that I would like to mention is the birth of Fortran. He recognizes that was a huge undertaking. Like, at the time, this was a project of great temerity. The people responsible for it deserve our great admiration. That was because that language raised the level of abstraction. Before that, you just used essentially machine language. But at the same time, after recognizing that was a huge success, he says, the sooner we can forget about Fortran, the better. For, as a vehicle of thought, it is no longer adequate. It wastes our brain power. It is too risky and therefore too expensive to use. Fortran's tragic fate has been its wide acceptance, mentally chaining thousands and thousands of programmers to our past mistakes. 7 years later, Kenneth Iverson, in Notation as a Tool of Thought, talks about mathematical notation. Mathematical notation provides the best known and the best developed example of language used consciously as a tool of thought. And he quotes Whitehead, relieving the brain of all unnecessary work. A good notation sets it free to concentrate on more advanced problems and in effect increases the mental power of the race. And he quotes Babbage, the quantity of meaning compressed into small space by algebraic signs is another circumstance that facilitates the reasoning we are accustomed to carry on by their aid. So essentially, because mathematical notation is so concise, you can contain a lot of meaning in just one line. So Iverson thinks that he can put together mathematical notation with a way of expressing software. So thesis of the paper is the advantages of executability and universality found in programming languages can be effectively combined in a single coherent language with advantages offered by mathematical notation. And this is what it comes with. That's trivial to understand. I was thinking maybe I should change these slides because according to the crowd that we have, at least yesterday, most people will be kind of familiar with this, but otherwise, normal people probably would find this kind of cryptic. But if you analyze the lines, I took this from Rosetta Code, and you can find a description of the algorithm. You can find that really, if you take a look at it, it's not so, it is weird. But there's correspondence between the lines. So first it checks the vector is larger than 1, and then it picks the pivot, and then it partitions all the items that are smaller than the pivot, the items that are greater than the pivot, and then it composes them together. So that's quicksort, right? Another hacker, Eric Raymond says Lisp is worth learning, because of the profound enlightenment experience that you get when you finally get it. That experience will make you a better programmer for the rest of your days, even if you never actually use the Lisp. So yeah, apparently for a lot of computer scientists, hackers, mathematicians, there is an influence between programming languages and the way, at least, we formulate our thoughts and we reason about software. But today, I don't really want to talk just about this, but also about do communities shape languages. So as I said, I'm Edoardo. I like programming languages. For the last year, I've been working at Tetrate as a contributor to a WebAssembly runtime called Wazero. It's written in pure Go, but I'm not going to talk a lot about that. But I'm going to, I wanted to mention also that I organize here in Milan the chapter of Papers We Love. And it's a community where we talk about papers, and you might have noticed the bias in the first slides. And so if you live in Milan or you live nearby, check it out. I'm going to share this later again. Anyway, I'm going to talk a little bit about my experience, and as we mentioned earlier, I'm going to talk also a little bit about Scala. Scala is a hybrid language between object orientation and functional programming language. So I was using this in my job, and then I was leaving that job, and I found an opportunity to join Red Hat. And so I talked to a friend of mine who's working there. They had an opening in their team. Oh, I would like to join you guys. And he said, oh, sure, you can come. We're looking forward to it. But I must warn you, here we do Java. It's like, and I said, okay, well, what's wrong with Java? I mean, you can say what's right with Java. Okay. But no, I mean, Java has come a long way since 1995. Java is an object-oriented language, but it came a long way after 1995, and it can be modern. You can write Java in a lot of different ways. So yeah, it was first released. The first beta was in 1995. It was the 90s, and if you recall, in the 90s there was also grunge, and the themes for grunge were social alienation, self-doubt, abuse, neglect, betrayal, social and emotional isolation, addiction, psychological trauma, and desire for freedom. So it shouldn't come as a surprise that they also came out with this book. But we should actually recognize the merits of this book, regardless if we like it or not. It contributes to advance the discipline of software engineering in a number of ways. So this book presented a shared vocabulary of patterns that people could talk about and reason about. And well, it was the years that people were using modeling to describe the relationship between components inside a software platform. So regardless if we like it or not, it has its merit. So this is an abstract factory, by the way. People using Java got overly excited about design patterns and tried to cram as many design patterns as they could in their code base, to the point that there was at some point this game online. You can find it anymore. I had to find a screenshot. It isn't even functional on archive.org, so I had to look up a screenshot. So basically, they generated 2 class names using a Markov chain, because we were using LLMs for everything at the time. And then it would present at least one class that was actually a real class name, right? And you'd have to figure out which one was the real one, and it was kind of hard. And I have no idea. There's also this script that you can run against the Spring code base to figure out which are the longest class names. The first, I hope it's internal, has this type pattern, try to sneak in some generic or parameterized type pattern matching stuff anywhere visitor. Abstract interruptible batch prepare statement setter. Abstract interceptor, well, you get it. I mean, that's and there's a bunch of factories too, right? Okay. So another thing that's peculiar, and I would say kind of defining of the style in modern, for some definitions, modern Java code base is the use of annotations. Annotation is not a concept that is native to Java. There are other languages that use annotation. It's just a way to attach metadata to parts of the language, like class types, definitions, members of these classes, and so on and so forth. So this is a way to define in a Java framework a complete web service that just prints hello, okay, hello world. And you might notice that there's no entry point. There's no visible entry point. You have no idea how this starts. And that's because this is declarative. You are not forced to use this particular style. You can also write APIs using a library, and this style probably is more familiar to most people using other languages. So you're not forced to use the first one, but you could argue that for the majority of people writing Java, maybe the first one is more idiomatic. But the question is, what does it mean to be idiomatic? So I would say that it's a matter of at least 2 parts. One is the design that derives from the language itself, and the other it's a matter of style, and that comes more from the way people use the language. So let's talk about design. Design of the language induces the developers to think of problems in a certain way, and the constraints of a language induce the developers to write code in a determinate way and find sometimes creative solutions. So let's talk about design patterns as well. So why did people came up with design patterns? Because they were trying to develop software, and in the framework of object orientation, they decided that there were some repeating patterns. One of these patterns is the strategy pattern, for instance. The strategy pattern essentially says you want to plug into some algorithm that pays for something, that implements a transaction. Different strategies depending on the payment that you want to use. You want to use a credit card, you want to use PayPal. So you have an interface, and then you have different implementations, different classes, different object instances. But you could argue that that's because the language did not really have a concept of closures or first class higher order functions. If you have a language that does have a concept of closure, you could avoid using a class, and that's actually irrelevant for the pattern. But having a name for the pattern is useful because you can talk about what you mean, right? What about visitor pattern? This is another feature, just another way to represent something that is actually implemented as a syntactic feature in other languages. And the visitor pattern is actually a way to do pattern matching. Now, nowadays, most languages, including Java, support a form of pattern matching, but at the time, there wasn't really a way to do that in a convenient way. So you could argue that design patterns nowadays, for the most part, are kind of outdated. The way languages have evolved have made them outdated, but it still has the merit of having this shared vocabulary and among developers. So as I mentioned, the constraint of a language induces developers to find creative solutions. And sometimes these creative solutions are useful beyond, in a way, their original intent. So I'm going to talk a little bit about Haskell. So Haskell is a pure type lazy functional language. And this is the way you write quicksort using Haskell. And you can notice that is pretty much similar to the way we were writing it in APL. It's a little bit less concise, but it's pretty much the same thing. There's the pivot here, and then there's the partitions here. All right, so as I mentioned, it's pure, it's lazy. So what does it mean to be pure? Pure means that you don't have side effects. So I'll try to simplify here, and pardon me if I'm oversimplifying. So no side effects in some sense means that there's no mutability. In a way, that means that, for instance, at the very least, you usually cannot vary the content of a variable. And in fact, there's no concept of a variable. They're called name bindings. So here you're giving the name x to the expression 1 plus 1. And actually, you can kind of use the one for the other kind of interchangeably. Not really. That's not really how it works. But in an abstract sense, you could. So you could refer to it by x, you could refer to it by 1 plus 1, or even by 2. But the thing is, computations are lazy. So the fact that x is bound to 1 plus 1 does not necessarily mean that 1 plus 1 is evaluated at the time the value is bound to the variable in general, in an abstract sense. They can be evaluated, especially can be essentially evaluated. You can think of it as if they could be evaluated at any time in the future. And that allows you to express things that in other languages cannot be expressed the same way. For instance, if you have a list of an infinite list, a range that starts from 2 and it's an infinite range, from 2 to the plus infinite, you could define a list of primes by applying the function sieve to all of the items in the infinite range. Obviously, this won't work in an eager language, a language where computations are not lazy, because this will be non-terminating expression, something that will run infinitely, right? But in Haskell, you can do that. So if there are no side effects, expression might be evaluated at any time, and results might be also cached, because if there are no side effects, evaluating the same function over and over again produces always the same results with the same parameters. So in an abstract sense, in general, I could also decide that if I give this function the same parameters, I could cache the result for those parameters, and if it's invoked again with the same parameters, it could return just the result without re-evaluating from scratch. But this doesn't always work. If we interact with a word, if we do I/O, for instance, if we print hello, what we want to see is hello on the screen once. But if we execute print another time, and we want that to be executed immediately, usually, we don't want it to be executed at some point in the future. If we re-evaluate print hello, we want it to print hello another time. So we cannot really cache the results, and then so on and so forth. So what about I/O? Yeah, and in general, if all functions are pure and lazy, how do we interact with a word? So there is this paper on the expressive purely functional I/O systems by Hudak and Sundaresh, 1989, where they think about this problem, and they present two solutions. So as they say, in functional language, if functional languages are to be used in real applications, an effective I/O system is essential. To many, however, the mention of I/O conjures up an image of state, side effects, and sequencing. So is there any hope of achieving purely functional and universal and efficient I/O in a purely functional lazy language? So before we got to the thing everything is thinking about right now, there were other strategies. One was called streams, and that's what they talk about in the paper. Streams were a list of requests, and then you apply this list of requests to a result, you apply a function to a list of requests, and it returns always a list of responses. These were streams. And the other solution is continuation. If you're familiar with futures and promises, this is pretty much what this is. That is, you read a file or you open a socket, whatever, and then instead of waiting for the result, you pass in a function, a callback, a continuation, and you handle the case for failure and the case for success. And if you wanted to chain the behavior, you have to chain continuations, right? So, burritos. So the stream style and the continuation style worked, but they weren't very convenient to write. So people realized that by applying a higher level concept, that was called monad from mathematics and category theory, and using this special syntax, you could write code that essentially looked like it was imperative, but what was really happening under the hood, you would actually be composing and sequencing functions. So monads brought effectful computation in a language that was pure, lazy, and functional without perverting it. So it wasn't just because we're fancy. That there was a real problem that needed solution, and it was just the right solution, at least at the time, that's what they thought, for the problem. And it preserved equational reasoning, obviously. Now, I mentioned that these solutions that we find as to solve one particular problem sometimes find application in other situations. And in fact, monads are in most languages, in a lot of languages, async await essentially is a specialized version of it. And we find it in many languages. And in Haskell, that's essentially not a special case. It's just an application of the do notation and so on and so forth. Let's talk about Rust now. Rust is a system programming language with a rich type system and a powerful macro support, to the point that macros are essentially the first thing that you learn. Well, the first thing you use when you encounter the language for the first time. This is a macro. The type systems, you will know, encodes constraints about values, but also the life cycles of these values. So the type checker or the borrow checker, the compiler is able to tell you if the lifetime about things about the lifetimes of values, and essentially through this machinery, it is able to allocate and deallocate and keep track in general of memory without using a garbage collector in a general sense. So as I mentioned, constraints. So this borrow checker puts some extra burden on the developers, and sometimes it forces them to reason in a certain way that might not be the most natural. And so I stumbled upon this blog post about Lua interpreter, and the author was writing this Lua interpreter using Rust, and he fought against the type system and the Rust language at first, and then he was forced in a way to write his interpreter in a certain way, and then he realized that actually what the language imposed on him made him create an implementation that was kind of novel, or at least interesting, and that could even be defined as sort of the killer feature of his Lua interpreter. So in a way, constraints can boost creativity. Now let's talk a little bit about style. Okay, this is quicksort in Python on the left-hand side and also on the right-hand side, but I read it in two different styles. The first one is very imperative, and the right-hand side is still imperative, but uses for comprehension, and you can notice that it's pretty much very similar to the one we read in Haskell. So the language doesn't really impose on you one style or the other. It's pretty much on you, but people might argue that the one on the right-hand side is more idiomatic, it's more Pythonic. Another example from the Java world, you might be familiar with the concept of getters and setters. These are materialized in Java by creating methods that are called getX, setX for instance variable x. This stems from also some guidelines that you can find still online on the Oracle website. Don't make any instance or class variable public. But if you continue to read, that will say, without good reason. So, often instance variables don't need to be explicitly set or gotten because they are modified and mutated by methods in your class. Now, if your class is a struct and it's just a data class, a data container, it's perfectly valid to have public members. And yet nobody does that in Java. Another interesting book, it's Effective Java. It's a collection of recipes and guidelines to write good code. One of them is refer to objects by their interfaces, because this way you can plug different implementations. So people said, okay, we should always use interfaces everywhere. So people started to create interfaces even before they start to write code. So they define an interface for a thing, and then the thing would only have one implementation, so they will create a class and call that thing impl. What? Usage patterns may influence the language too. We talked about annotations and how you can write using annotations or using a different style, but where do annotations come from? Did the language developer just came up with the idea? Well, actually, before annotations, the language did not always have support for annotations, but what people started to do was adding stylized comment in their code and then create ad hoc tooling to process that code. So the language developer said, okay, that seems like a reasonable use case, so let's create some specialized syntax in the language and tooling to support that particular use case. If you're wondering what this is from a framework that was called JML to do essentially contract-based programming, so checks invariants and stuff like that. So yeah, now you have annotations, you can annotate your members with constraints, and again, people got super excited about it. And this is the code that sometimes annotations, yeah. So nothing in the language really forces developers to write code using that particular style, but the community adopted this style, making it kind of a prevalent style. Let's talk a little bit about Go. So Go, that I've been using this year to work with Zero, you might think it's very different from Java, but I would argue it's kind of similar in many ways. They both have a sort of a large runtimes. They're both garbage collected languages, and they have support for abstracting over operating system threads. Now, one thing that obviously is different is the syntax, and they definitely have a different form of inheritance. In Java, it's class-based, and in Go, you have interfaces that work in a different way. But okay, the other thing that is not really deriving from the way inheritance works is that Go tends to have very shallow type hierarchies, while Java tends to have very deep type hierarchies. That probably comes from the excitement in the 90s and early 2000s about object orientation. The other thing that's different between the two ecosystems, and that does not derive from the language, is that people using Java tend to like frameworks, and people using Go hate framework and tend to use tiny libraries. So that's style. Another thing I wanted to mention, if you're familiar with this was a code base by Rob Pike. People really wanted to see in Go filter, map, and reduce combinators. And Rob Pike didn't really like that, but he said, okay, let me try. I wanted to see if I could implement this. And there's this code base that is like 10 years old or something. I wrote it, and you can actually make it work. And it looks kind of nice, but having written it a couple of years ago, I haven't had occasion to use it once. Instead, I just use for loops, and you shouldn't use it either. So that's a statement. It's a statement about how you should write code. You can write code this way because we have higher order functions, we have closures, but it doesn't add much to clarity. So I believe, as a language developer, as a developer of the Go language, that you shouldn't even use it. So the language does not push developers towards that style or against that style, but the community decided to follow the advice and not adopt this style. So in Go code bases, mostly you will see for loops. So let's talk about Scala. Scala is a hybrid object-oriented functional programming language that I said already. And as I said, Haskell is a pure type-lazy functional language. I wonder if you know where I'm going. So Scala is an eager, impure hybrid language. So you can really write print and expect it to print. You can read a line, expect it to wait for user input, and then print the output. But you can also, write it using a different style. Over the years, the typeful functional style has become kind of more prevalent. So instead of this, you will see some code bases using this style. And to me, it's kind of uglier, but there's a reason for that. So the for comprehension was not really meant to be used in this way, but people are using it this way anyway because they believe, that's legitimate. They believe that this style has a lot more. It has the same benefits of the Haskell style. So you can reason about, you can have equational reasoning. I/O won't be performed in random places. You can contain it. You can rewrite the meaning, and so on and so forth. So it has benefits. But why is the for loop, which is called actually for comprehensions, kind of ugly with respect to the do notation? Well, because one of the things is that Martin Odersky, who's one of the creators, the first creator of the language, does not really want people to use it that way. And still the community he's using it that way. He makes fun of this style of Scala and call it Haskalator because it's very reminiscent of Haskell. And so here's Zygomorphism. Zygomorphism is one of these higher level abstractions that you can apply to your code. I'm not going to go into what that is because honestly I don't really understand it. But once you have these tools in your tool belt, you can apply it with a very high level of abstraction to your code base. Now, they do have a learning curve, right? So when you adopt this style, you have to decide, you're making a choice in your code base. You have to find people that you think will be can get familiar with the style, and you're also making a statement about sourcing people that in the future will be able to maintain this code. But you can also argue that maybe this is not significantly more complex than design patterns. So after all, with design patterns, we're just familiar. With this style, maybe we're just less familiar. But I also want to talk a little bit about this snippet of code that was on Twitter about TypeScript. A tie here says, the ceiling has been raised. Copilot has helped write superhuman code for a critical feature. This is a type definition. We can read this code, but very few engineers out there could write it from scratch. And took a lot of convincing too. So there was immediate backlash from Twitter. A lot of people said, why would you write that? That's so complex. Can you really read that? I mean, you say you can read it, but let's think about like in a few weeks, can you still understand what's written there? So is this significantly more complex than design patterns? It depends on, again, depends on you, it depends on your style, and so on and so forth. A few days later, Adam says, the funniest thing about the recent TypeScript discourse I caused is that this code had a bug in it. I've had dozens of devs tell me my code is garbage, but not one spot the bug. I'm disappointed. Yeah, why do you think nobody found the bug? Why? Okay. Let's talk about Rust. So Rust is a systems programming language with a powerful type system, and it allows you to use higher level abstraction. This code is made a little bit more unreadable than it should be because they're not importing some of the packages here. But the cool thing is about this phantom data here, which is not consuming any data, but is still hinting the type checker some information. So you can write very high level code in Rust, and that's a good point. But I think that's a power that you have to use consciously. There was this blog post that I found, Gentle Intro to Type Level Recursion in Rust from 0 to H list sculpting. So this is an implementation of heterogeneous lists. And it starts like this. As a Scala guy with Haskell knowledge, I'm no stranger to type classes. But it took me a while and several failed attempts to figure out how to implement the following. This is a picture from the blog post. He put the WTF on the page. So I'm not going to go into the details of this. It is using type-level recursion to describe heterogeneous lists. Not going to explain what that is, but you can easily get to a degree of sophistication in the type system of Rust that is very powerful. But you should ask yourself, is this worth it? And I mean, it's fun. It's actually an exercise that I've done myself. But it's very easy to go from fun to let's go to production because it's cool. And then where's the balance? So is it Go? Well, okay, I don't know. Go didn't have generics for a long time. People rolled their own using, I don't know if you've ever seen this one, the Canadian Aboriginal syllabus block. They use that in identifiers and then use glorified search and replace to instantiate generics. And that was kind of funny. And then finally, the developers of the language introduced generics, but then the type system was kind of evolved over time. So introducing generics at that time wasn't painless. So that's a cost. So let's talk about Zig. Honestly, I'm not going to say much about Zig. Zig made some choices, and making choices and not making choices is also making choices. So it tries and strives to be a simple language. It does not come with literally a macro system, but with comp time, which is another way to do build time computations. And you could argue it's simpler in a certain way. Maybe you could argue it's more complex in other ways. So let's talk about Rock. So before I started working on this talk, I already had the abstract ready. I remember rock is in the, Elm, lineage. And I remember something about monads. And then I checked on their frequently asked question, and this really resonated. Rock will never support higher-kinded polymorphism. It's important to consider the cultural implications of deciding whether or not to support it. If the language does support it, one or more alternate standard libraries built around monads will inevitably follow, along with the corresponding cultural changes. See Scala. Culturally, to support higher-kinded types is to take a side, and to decline support for it is also to take a side. So, do languages shape thought? Well, maybe. Do communities shape language? I think so. Conclusions. The design of a language imposes a certain way of writing code, and design constraints induce a particular way of reasoning. These constraints, at times, boost creativity in possibly unexpected ways, and polyglot programming is a way for you to unlock new ways of thinking about the same problem. But developers do have agency. In a lot of ways, the way you write code is not just induced by the design of your language. You have a say in what constitutes idiomatic code. And in a team, members should pick a style that follows their skill and preferences, keeping an eye on maintainability and talent sourcing. And in a community, language developers have a say in designing guidelines and enforcing constraints, knowing that people might ignore them. Simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. And to make matters worse, complexity sells better. Thank you, and that was all.
Thank you, Edoardo. Thank you very much. So, let's hear questions from the audience. Do we have any? Can I see any hands? Anybody from the Scala camp? Any complaints, actually?
They'll wait for me outside.
Oh, yeah. They went to buy weapons. So, well, thank you very much for your talk. From the perspective of being involved with the creation of a language, certainly the perspective of thinking about what the community is going to do with the language and the question of whether how much you should try to influence it or not, it's definitely very real. Obviously, you want to. It's not like you know everything, right? So obviously, people should use the tool, and maybe they will surprise you in good ways. That said, there's also some things that I don't know. At least I personally consider to be so far away from what I feel like it's idiomatic that it does feel like I should maybe try to push back against certain things. Like, for example, in Zig, I've seen quite a few, not all of them, but quite a few like string libraries. Zig doesn't have a dedicated string type, and there is a lot of discussion about it, which, by the way, I'm looking forward to have eventually after we're done with talks. But some people made wrappers like tiny libraries that basically provided what already was there, just under a string namespace. And it's slightly worse than what the standard library already has. Another interesting one was, which also is close to what you mentioned, map reduce and filter, which is not exactly super idiomatic in Zig. But yeah, at the same time, who knows? Maybe it turns out that they're not all that bad to have. I have no idea. Do you have any perspective on any specific thing that you like or don't like that you've had to deal with in your programming experience?
Well, yeah, I mean, I feel like, so the whole point of the presentation was that I myself, maybe that wasn't clear, but I myself have experimented a lot with playing tricks with a compiler and the type system of a language, and that's super fun. But that can be a turn off as a developer and a maintainer or a newcomer to a code base, because this highly advanced usage of the type system, of the features of a language can become very hard for someone to get on board. So I believe that one has to find the right balance between advanced features and sometimes make some compromises depending on the people you're working with, because sometimes the people you're working with do not like the style, or one feel comfortable with it. And so you have to take that into account.
Yeah. So when I gave an interview on YouTube. I was like on a podcast called Developer Voices a while ago, and I remember making this comment where I said that people write code that is too abstracted occasionally in some other languages. I think I was complaining about C++. And one of the comments on YouTube, which are a great source of wisdom, as everybody knows, was pointing out, wait, is this guy saying that abstracted code can be less understandable? That's the whole point of abstraction. Has this guy ever programmed in his life? What do you think I should reply?
I don't know.
I shouldn't reply.
Yeah.
Okay. So, did we get any question in the meantime from the audience? Oh, yeah, we got one up there.
Oh, there's one question. There's two questions, actually. Or three, I don't know.
Did we lose our ghost? Oh, I think we lost our ghost.
Thank you. A philosophical question. We can say the software today is shaped by the decision of communities and language design of the past. And in your opinion, how many of this decision was intentional or was casual, random? Thank you. Does it make sense, my question?
Yeah. Well, I don't think they were random in general. I think that probably people did not have an hindsight on many things. So in the past, we have experimented with a lot of stuff and we realized they weren't great ideas or they didn't work as we wanted. Like, first example that comes to my mind of being also a Java developer in the past is checked exceptions. So exceptions get checked by the type system. People hate that. But we are actually kind of implementing that in other ways using return values and errors in return values. So it's not exactly the same thing, but we have the experience of the mistakes of the past, mistakes that weren't considered mistakes in the past. And so we can just improve our languages. The problem is, unfortunately, once you have a feature in a language, it's very hard to remove it. So the languages of the past can only grow. And so they can get better, but the code bases that you had from the past are still there and will always be there, probably.
Yep. Any other question? I see one here.
Yeah, I think that you are very right when you say that you have to find a balance. But the problem is it's often difficult because you understand implication after you have experimented with it.
Right.
And that's also why I had, for example, the experience in Scala that you have many libraries that, for me, for my feeling, go a bit too far in experimenting with feature of the language, that we should really go back and think of the whole relationship that it was then, and what the end user is, and the whole thing, and see if the thing brings something. And generally, the simpler you can stay, the better. And but it's difficult. it's always a trade-offs.
Yeah, I definitely agree. I mean, you have to find the right balance depending on the people that are in your team, the people you work with, and obviously you can make mistakes. Mistakes are allowed. It's important to recognize that you made a mistake, though.
So Andrew was commenting that he's disappointed that you didn't roast him enough. So do you have any complaint about Zig?
Oh, I'm not experienced enough with Zig to complain. So no, I don't have any complaints, honestly.
Next year, next talk.
Yes, talk.
Okay, more questions?
Yep.
Ooh.
I just wanted to say that, like, I was previously like a functional programming fan. Then I was like got disillusioned with it, but now I'm getting into
You're recovering.
yeah. Now I'm getting into numerical linear algebra, and most the stuff that you do, it is like just multiplying matrices, which like can be like I don't know, an oversimplification, because matrices internally have a lot of structure, and like there are various ways in which you can multiply matrices. But I think it is like good to keep in mind that what you are doing at the end, it is that. And so for some of these abstract patterns, it may not be like worth to have it in the language. So I don't think it is worth to have a language that as a primitive type, diagonal matrices, block matrices, whatever kind of matrices, and then it can magically implement them for you. But maybe just like write a comment. Hey, by the way, yeah, we want to do a kata morphism, whatever. So we are trying to maintain these invariances, but like, since we know that you're in this very specific case and not in magic math land, we can take a bunch of shortcuts. And yeah, but this is what we are trying to do in the abstract. So for numerical linear algebra, it is, at the end of the day, always matrix multiplication, but very specific. And most software can be like identified as like map and then reduce, like there are entire frameworks around this. But there are some invariances that you can maintain, and I think it is worth keeping in mind. Like, and it is not necessary to have it in the language. Just this, a comment more than a question.
Yeah. So no, I agree, and that's also part of the balance I was talking about. Like, so in a language, depending on the language you pick, for instance, Rust. With Rust, you have a wide array of possibilities when it comes to building abstractions and doing computations. You can do a build time. I don't think you can use a form of reflection. That was kind of controversial at some point. But there are languages where you can use build time computations, some form of reflection, and you can be very biased towards build time computation or very biased towards reflection. And if you find the right balance, probably you find a good balance between being easy to understand and powerful enough, so to speak, without being too biased in one direction or another. I think that's what you meant, essentially.
So I was wondering, what do you think about TypeScript and the TypeScript type system with this, like how languages shape communities and vice versa? My feeling is that the TypeScript system is quite extreme, actually. Like, you can do things in it, and I'm wondering if like this kind of joke AI generated type, if that's like that's the future that TypeScript is leading people to, like, in a way.
Yeah, good question. So TypeScript, I mean, the TypeScript language has a powerful type system, and that's a tool. And as I said, you can choose to use the tool in a very extreme way or be balanced in the way you use that type system. So it's up to you whether you want to use it in a very extreme way or not. So the TypeScript language the developers that use TypeScript, it's up to them deciding whether they want to be extreme or not. And also, I remember one thing that I wanted to say to the previous person. It's interesting also with respect to the idea of choosing power and in adding features to the language. It's interesting the strategy that the Rock developers are using. They're refusing to add higher kind of types, but they're experimenting with other solutions to do effects in a pure language. And that's interesting. That's actually powerful.
Okay, my question is, if you could make one wave magic wand, make one change to one language, what language would it be and what change would you make?
Oh, crap. I would like Rust with a garbage collector. Was that enough controversial?
Thanks. Great talk, and I think it stimulates kind of question patterns like the following. I make a statement and I'll ask you your opinion on that. We have had a question pattern like this. So one of the things that made me think is that the way you style the code and the community interacts is also related to the cognitive load that you have when you read the code. So a community, the people that are reading or also writing, let's focus on reading the code.
Right.
The styles and the idiomatic styles goes in the direction of keeping the cognitive load low. So I don't know, you keep a style because you're focused on safety or something like that, and that style gives you guarantees, or you are used to that.
Right.
So, what's your opinion on that? Apart from
I haven't understood the question. Sorry.
The question is, I make a statement. What's your opinion about this? The cognitive part? You can. If you have
Right.
something more.
So yeah, that's a good point. So we mentioned that earlier, like with APL, which is obviously not a language for everyone, and there's various dialects of APL that are still used nowadays. And the benefits of APL is that you can compress a lot of meaning in a line of code. And as you write, you use a lot of the type system. And you use this higher level abstractions. The idea in theory is that you can raise the level of abstraction, yes, but also you kind of reduce the cognitive load because you don't have to come up with different solutions over and over again to problems that actually are similar, because you recognize the similarities because you reason at a higher degree of abstraction. Again, I think, and unfortunately, if this was Twitter, people wouldn't like my answer because it's going to be, nuanced. But it depends. So it depends on the people that you're working with, and if they believe that they want to spend the effort to get to that degree of abstraction, which obviously it's a cost. But again, it's a cost just as much as it's a cost having to learn object-oriented design patterns. So it might be worth it.
Hi, I have a quick question that basically relates with that one. Do you think in general macros are a good idea? Because, for example, I write Clojure from time to time, and if you write a macro, you basically design a new language. You have this libraries called Core Async, which is basically Go style programming in Clojure. In Rust, you can do the same. So are they too powerful for a language?
If your language doesn't have macros, people are gonna do code generation with, their bare hands. So
unnecessary evil, basically.
So it's worth it having it probably in the language if you know that people might want to use it.
With respect to it depends. There is always the classical what is easy and what is simple.
Right.
And I think many of the things in the community, it's because in that community that way of expressing, it's easy, it's common, but it's not necessarily always the simplest one. It depends on the problem.
I think let's stop here. I think you guys should have this discussion during lunch because I feel like there's a lot of opinions. I'll share just one last closing thought because we talked about language features, but I think there's another class of features which is still related to languages that interacts very heavily with the community, where I think there might be an interesting phenomena. That's my theory, but I'm looking forward to see what happens soon in the Z community. And I'm talking about the package manager. Obviously, package management that's heavily influenced by the community. And in Zig, for example, we made two interesting decisions, in my opinion. One, I guess the most interesting decision is to not have an official package index. So we have an official package manager, but we don't have an official package index. And that comes with a set of trade-offs, and things could go well or not. And there's a second feature, a minor one, but I think looking at that one can also give us interesting insight on the first one and also other ones. The second minor one is a proposal that I made a while ago, chatting with Andrew, which is to have V1 packages only be able to depend on other V1 packages. So if you publish a V1 package, you cannot have a V0 point something dependency. Obviously, it's a controversial decision. Do I know for sure it's going to be a good idea? No. Do I think it's going to be a good idea? Yes, otherwise I wouldn't have proposed it. But I've received some feedback where people said that there could be some unintended consequences that, again, they didn't sound too realistic to me as the person who proposed the idea. But here's my thought that I think is interesting. I suspect that what might end up happening could be either my vision or their vision, and maybe it might even boil down to what ends up happening in practice, as in like a fully chaotic dynamic system that heavily depends on the starting conditions, right? So the idea could be that maybe their concerns are equally as valid as mine, but then depending on what ends up happening, like to the actual people working on things, either the proposal is great or it sucks. And in the end, it's not something that you can decide like in a room. It just, you have to roll the dice and see what happens.
Right.
In our defense, the V1 restriction is something that you can lift without breaking anybody's code. Like at some point you decided it's a bad idea, and you start allowing that.
That's
so
right.
Nobody loses anything. But in any case, so I think that thinking about how communities shape the language and vice versa is a huge topic. So I invite everybody to discuss that stuff over lunch. Please give it up for Edoardo one last time.
Thank you.
Okay, let's go on a break now, and we come back in about 10 minutes for the next talk. Thank you.